Hello everyone, my name is G. Shankar Varma, Assistant Professor from EC Department, belongs to Marri Laxman Reddy Institute of Technology and Management. And now I am going to teach a subject called Integrated Circuit Applications. And it is for third year EC students. And prerequisites of this subject is electronic devices circuits, digital system design. These two subjects are prerequisites, and those two subjects students already studied in their second year. Now, this subject integrated circuits applications will be in third year. So, coming to the topics, what I'm going to tell about in this presentation is course objectives, course outcomes, course syllabus of this particular subject, and apart from that, introduction of operational amplifier, classification of integrated circuits, basic concepts of operational amplifier, IC741 operational amplifier and its features. Operational amplifier, short form we call it as generally op-amp. So next, coming to the course objectives. Course objectives are nothing but student will try to learn basic building blocks of linear integrated circuits and theoretical aspects and applications of multivibrators and voltage regulators, analyzing the various concepts of active filters and PLL. PLL means phase locked loop. And to how to develop different kinds of analog to digital and digital to analog converters. And also to design and analysis of various combinational and sequential circuits. Now coming to the course outcomes. After successful completion of the course, students shall be able to understand the basics of operational amplifiers and integrated circuits in analog and digital circuits, and to identify the applications of operational amplifiers and integrated circuit timers like IC555 timer, and to analyze analog to digital and digital to analog converters for accuracy and suitability, and implementing digital systems using combinational logic integrated circuits, and to apply sequential logic and memory for practical circuit design. Coming to the syllabus of this subject, the first unit totally consists of integrated circuits and operational amplifier. In the unit 1, students will learn about what are the various basic concepts of operational amplifier. Like, first of all, we will see how the particular this electronic device got that name, like operational amplifier. In the very olden days, in analog computers, for doing the mathematical operations, this exclusive electronic device called operational amplifier is used. That's why it is named as operational amplifiers. It will do mathematical operations like addition, subtraction, division, logarithmic, anti-logarithmic, etc. So in this unit 1, students will learn basic fundamental concepts of IC741 op-amp and applications. And unit 2 completely about applications of op-amp. Apart from that, IC555 timer and IC565. IC565 means phase locked loop. IC555 means it is a timer. And coming to the third unit, students will learn about various kinds of analog to digital and digital to analog converters. And coming to the fourth unit and fifth unit, it is completely about digital part. That means in the earlier slide in the beginning, I told about the prerequisites for this subject. One of the subject called digital system design. Their students will already learn about these topics, but in that subject, they will learn very basic concepts of few combinational and sequential circuits. Apart from that, here in this subject, students will learn how those digital electronic devices will be fabricated in the form of IC or available in the form of IC. Those concepts students will learn in this subject. So fourth unit mostly covers the combinational circuits like encoders, decoders, multiplexers, demultiplexers, etc. Fifth unit mainly covers about sequential circuits like flip-flops, counters, registers, etc. Along with that, in the fifth unit, memories, various kinds of memories will also get introduced. Memories like random access memory, read-only memory like that, RAM, ROM, etc. Different types of RAM, different types of ROM. Along with the architecture, students will learn. So coming to the textbooks, two standard textbooks are highlighted here. One is Ramakant Gaikwad and second one is Floyd Chain. Apart from the standard textbooks, few references also here suggested. One is Roy Chowdhury and second one is Operational Amplifiers with Linear ICs, authored by K. Lal Kishore. And another third one is Linear Integrated Circuits and Applications, authored by S. Shalivahan. So these are the textbooks and reference books of this particular subject, integrated circuits applications. And coming to the introduction of IC, so here I have written just the definition of IC before going to start about the definition of IC and all. If you observe this figure 1, it consists of different input and output terminals. This left side inputs will present and right side outputs will present. This middle part we call it as generally IC, integrated circuit. So this package is called dual inline package. Dual inline package means number of inputs present at left side and number of outputs present at right side, both count should be same. That is called dual inline package. Different kinds of packages will be there, but in general most available ICs in the market is dual inline package ICs. So here I have placed IC741, which is operational amplifier IC. So apart from this IC741, IC565, IC555 timer ICs and all, in general in our day-to-day life, wherever if we will see these electronic devices, most of the devices consist of integrated circuits only. So like our television internally consists of IC. If you open the television, internally you will observe the ICs. And if we see about laptop, if we open it along with the motherboard, we will observe some integrated circuits only. So in our day-to-day life, many electronic gadgets consist of these integrated circuits. So coming to the classification of integrated circuits based on the application, based on the chip size and circuit complexity, based on manufacturing, the IC is going to be classified. We will see one by one. So coming to the first classification of IC, that is based on application. Again, it is subdivided into two types. One is analog IC and second one is digital IC. What is analog IC? Analog IC is nothing but the IC will takes the analog signal as input and it will process and it generates analog signal as output only. Best example is IC741 op-amp, which will take only analog signals. Examples of analog signals are like sine wave, square wave, triangular wave, sawtooth wave, etc. Those are all the examples of analog signals. Coming to the digital ICs, the digital IC will take digital signal as input and after processing it will generate a digital output. Digital signal is nothing but binaries like ones and zeros. For example, I will write a small digital code that is 1101. We call this one as a digital number or digital data, right? So best example of digital IC is 74138 decoder. So students will already, as I said, already studied about this 328 decoder in their digital system design subject. But the thing is, which kind of IC is they have to use for this operation 328 decoder, that they will learn in this subject. So coming to the second classification, that is based on chip size and circuit complexity. Here 4 types of ICs are available and number of transistors also given in the right side of the table. Here total 2 columns we have taken. One is the first column is about IC type and second column is the number of transistors per chip. Per chip means per IC. Coming to the first type of IC, that is small scale integrated type kind of ICs, those are having 100 transistors per IC. And coming to the second one, that is medium scale integration, it consists of 1000 transistors per IC. Coming to the third one, that is large scale integration, it consists of 1000 to 20,000 transistors per IC. Coming to the fourth one, very large scale integration, VLSI, It consists of more than 20k transistors per chip. Around 10 power 6 transistors per chip we can use. So coming back to the definition of IC, if we observe, the integrated circuit or IC is a miniature low-cost electronic circuit which consists of active as well as passive components that are irreparably joined on a single crystal chip of silicon. If we observe carefully this definition, here two kinds of components present in the IC. One is active component, second one is the passive component. So active components are nothing but those elements is used for generation of some power, like voltage source and current source. These are the examples of active components. Along with that, transistor is also an active component. So next, coming to the passive components are nothing but resistor, inductor, capacitor, etc., which is mainly, these elements are mainly used to store the energy. That's all. So coming back to this table, here we are talking about, in the second column, here we are talking about number of transistors present in the chip or present in the IC. So as per the definition, so this IC consists of passive components as well as active components. Transistor is one of that active component. So that's why we are discussing about number of transistor present in that IC. So this is about the based on chip size and circuit complexity. And coming to the third kind of classification of integrated circuit, that is, it is of mainly two types. One is monolithic IC and second one is hybrid IC. We'll see one by one. Coming to the monolithic IC, here components are fabricated on the top of silicon chip. But coming to the hybrid IC, here fabrication of components will be placed by using wire bonds. Coming to the second part, identical components are connected. Coming to the second point of hybrid IC, here non-identical components are connected. We will see what is the second part. Like if you consider a 4-bit adder, 4-bit adder is nothing but, for example, let us consider a full adder. We will connect, if 4 full adders, we call it as a 4-bit full adder circuit or 4-bit adder circuit. So in this 4-bit adder circuit, what we are connecting? 4 types of full adders only. So same components we are connecting. That will, we can write an example for this monolithic IC. Coming to the hybrid IC, coming to the filters, if we study about the wideband filters, so there we will connect low pass filter along with that high pass filter. So low pass, high pass filter, both are different, both working are different. So two different components we are connecting for a single purpose. So that we can write an example for hybrid IC. That is the meaning, actually non-identical components are connected. For monolithic, identical components are connected, like that. Coming to the third part of monolithic IC, here performance is poor when compared with hybrid IC. Obviously for hybrid IC, high performance will be there. Monolithic IC, as usual, performance is poor, the cost will be low. Hybrid ICs, here we are highlighting that cost is high. That means performance is also will be obviously high. So this is about the classification of integrated circuits. So coming to the operational amplifier, as I said, this is the symbol of operational amplifier or op-amp. As I said earlier, in the olden days, in analog computers, to perform different mathematical operations, these operational amplifiers are used. But nowadays, these operational amplifiers are available in IC form, and the IC number of the IC operational amplifier is IC741. Students have to remember this IC numbers, but because in the exam they will ask a simple question like this, for a short answer question like this, draw the symbol of IC741. Then they have to remember, okay, we have to draw the IC741 op-amp symbol, like that they have to remember. So again I am repeating, IC741 is the IC number for operational amplifier. Okay. So coming to the operational amplifier, small introduction I have written. That's all. It has two input terminals. One is positive terminal. Generally, we call it as a non-inverting terminal. And the second one is a negative terminal. We call it as inverting terminal. The name itself indicates that non-inverting means positive. Inverting means reverse means negative. And this is output of operational amplifier. If you observe carefully, here two voltage supplies are there. One is V plus and another one is V minus. Generally, that's why we call the operational amplifier as a dual supply. It will use two supplies. And coming to the last part of our presentation, that is pin diagram of op amp and few features of this particular op amp also I have written. Coming to the pin diagram, as I said earlier, these ICs are available in various packages, but generally IC741 op amp is available in dual inline package. What I said about the dual inline package consists of same number of inputs as well as same number of outputs. If we observe another thing, numbering also given for these terminals 1, 2, 3, 4 for at left side. We started counting again from downward to upward, like 5, 6, 7, 8. So if we observe one point, the first pin and the fifth pin, we have written same wording here, that is offset null. I will give you small introduction about this. What is the meaning of the offset null? Why we are writing like offset null? Offset values will be there in generally. If we are doing experimenting with these electronic devices, sometimes we will get the offset values. Offset values means, let us assume an electronic device. We are not applying any input. In that case, we have to get zero output, or the value should be zero. But apart from zero, if it is generating any other value, maybe any other positive value or negative value, other than zero values, non-zero values, that means something what we call it as some little bit of damage, or it is not functioning properly, that electronic device is not functioning properly, that we can conclude. Again, I will repeat for your understanding sake. Let us consider an electronic device and we are applying a zero input. What we will get as output? Simply zero. But other than zero, if we are getting any other output, those output values are called offset values, and those values are the errors. We don't want that values. Okay. So how to remove that offset values? That concept is called offset nullifying or offset null. That means we will make those values as zero. That is the concept of offset null. Simply we will connect a potentiometer between this pin 1 and pin 5. We will adjust that potentiometer or pot in such a way that until we will get the offset value as 0. And coming to the second pin, third pin, we have seen earlier these two, second pin, third pin. Those two are the input pins. And coming to the V minus, V plus, those we have seen in the symbol, right? So supply, fourth pin and seventh pin. Fourth pin and seventh pin. Sixth pin is the output. Sixth pin is the output. So mostly all the pins we have covered, but if you observe, we left with one more pin, that is called no connection pin. That simply we write it as NC. NC means no connection. We are not going to connect any component or any element to this particular pin. If we are not using, we may get a doubt. We are not going to connect any element or any component to this particular pin number 8. Why pin number 8 is there? Why that extra pin is there? As I said earlier, we have to follow dual inline package structure. Dual inline package means same number of pins count should be matched for the left side as well as right side. For that purpose, no connection pin is used. Coming to the few features of operational amplifier, the power consumption is very low and short circuit protection will be there. Offset null voltage capacity will be there. We have already seen what is the offset null. Offset null, again I am repeating, remember this, if we are not connecting any input, we are getting some values, those are called offset values. Why I am highlighting this word offset means, in the characteristics, in the characteristics of, I will show you. In the first unit, we are having some DC and AC characteristics of operational amplifier. There we will study again this offset null concept. Okay, so that's all for today. So we have seen very few fundamentals or basic concepts of operational amplifier. In the coming video lecture classes, we will see different concepts or different applications of operational amplifier. That's all. Thank you so much.